The joint PDF of x and y is given below. Find variance of x plus y by 2. So now we know that variance of a constant times a variable, the constant gets squared. So it would be 1/2 squared. Constant here is 1/2. It's 1/2 times x plus y. So it'd be 1/2 squared times variance of x plus y. And then the variance of x plus y we know is variance x plus variance y plus 2 covariance xy. And therefore we will need to find all these three things. And variance x, you know, is e of x squared minus ex whole square. So we need to find ex and ex squared. So ex, you know, is the double integral of x against the PDF. So it was 0 to 2, 0 to 2 for the PDF, and it's x plus y by 8. And you pull the 1/8 out, you multiply the x with the x plus y, so x squared plus xy, and now you integrate it. Y is a constant, so x cubed by 3 plus yx squared by 2. And then you put in x equals 0 and x equals 2, and you end up getting 8/3 plus 2y here. And then you integrate with respect to y. So this is 8y by 3 plus y squared, and then you put y limits. And you end up getting e of x equals 7 by 6. E of x squared will be the same thing repeated. Now you have x squared integrated against the PDF, and we end up with 5/3. And variance of x is e of x squared minus ex whole squared. So it would be 5/3 minus 7 over 6 whole square equals 11 by 36. Now, if we go up and look at this PDF, it is completely symmetric in the two variables. See here, and by complete symmetry, I mean that if you look at the PDF formula, it doesn't matter if you interchange the x and y, it stays the same. And here also x and y have exactly the same bounds. So that's meant by complete symmetry. So whenever that happens, that the PDF is totally symmetric in the two variables, then the expected value and the variance of the two variables is exactly the same. So we have calculated the expected value of x and the variance of x, and y will have exactly the same expected value and the same variance. And this would be, okay, let's go back. Okay, so yeah, so we're writing here that y has the same x expected value is 7 over 6, so it would be for y, and the variance of x was 11 by 36, and that would be the variance of y as well. And now, if you remember, we also need the covariance, and for that we will need the expected value of not x comma y, but xy, e of xy. Yeah, let's write brackets. E of xy, because covariance is e of xy minus ex ey. So therefore you do need e of xy to get the covariance. And now you integrate the PDF against xy, the same business as before. And we end up getting 4/3. So covariance xy equals e of xy minus ex ey. So that's 4/3 minus 7676. So that's negative 1 over 36. So covariance can be negative as well. Remember, variance can never be negative, but covariance can be. And now we have everything that we needed in that formula, variance of x plus y by 2. We figured out on the top that it was 1/4 times all this. So you substitute the values. The two variances were both 11 by 36. Covariance was negative 1 by 36. We end up 10 over 72. They didn't simplify this answer, so I also didn't. And that was choice A.